Hey, what's up, guys? So today we're going to look at the past exam question paper under Newton's laws of motion and see how we can apply the information that you have learned from the first video. So as you can see here, it says that two blocks of masses 20 kg and 5 kg respectively are connected by a light inextensible string P, a second light inextensible string Q attached to the 5 kg block runs over a light frictionless pulley. A constant horizontal force of 200 newtons pulls the second string as shown in the diagram below. The magnitude of tension in P and Q are T1 and T2 respectively. Ignore the effects of air friction. So from the information that we're given here, we can actually see that the main important thing here is we are going to ignore the effects of friction. So question 1.1, state Newton's second law of motion in words. So this should be very easy. So Newton's second law of motion states that when a resulting force acts on an object, the object will accelerate in the direction of the force. This acceleration is directly proportional to the force and inversely proportional to the mass of the object. Right, let me just write it down. So this part that I underlined with red here, you can actually recall it, or you can get it from the equation. Acceleration is equal to F net over the mass, which we can convert this part here to be directly proportional. So in this case, we are simply saying that if an object experiences a net force, then it's going to accelerate in the direction of the net force with the acceleration that is directly proportional to the net force and inversely proportional to the mass. So you can see acceleration is directly proportional to the net force and acceleration is inversely proportional to the mass. So that's how you can recall this law. Okay, now let's move on to question 1.2. On question 1.2, as you can see, they say draw a free body diagram indicating all the forces acting on the 5 kg block. Okay, one thing that you have to take note of is that we have allocated 3 marks for the free body diagram. Hence, that means it's going to have 3 forces, or we're going to have to draw 3 forces. Okay, so the way that I suggest you do this is first by drawing the free body diagram or the forces on the actual diagram that you'll be given, and then you can draw your final answer in your answer script later on. So as you can see, this is our 5 kg block that we are interested in, and on this diagram you can see we're going to have a downward force for tension, an upward force for tension, and in addition to that we are also going to have a weight, and then you can see this will be our 3 forces. Right, so our free body diagram is going to look like this, where the dot is going to represent the 5 kg block, and we have an upward force which is in this case tension 2, and we also have our tension 1 and the weight, which we can also call Fg. So that will be our free body diagram. On question 1.3, they are saying calculate the magnitude of tension T1 in the string P. Right, so as you can see in this question, we're going to have to solve this problem using a simultaneous equation because we don't have the acceleration, and neither did they mention that the object is at rest or moving at a constant velocity. Hence, we are going to assume that it's going to accelerate. So we are going to solve the problem simultaneously or using simultaneous equations, so those using the second law of motion. So first we're going to formulate our equations. To formulate our equations, we use the free body diagrams. So we have to draw both free body diagrams So because of that, I'm just going to draw the other free body diagram. This one is for the 5 kg. I'm going to draw the one for the 20 kg. So we're going to have our tension, and this is going to be tension 1, and we're going to also have weight. So let's formulate the equations. Is equal to mass times acceleration. Hence, so for the 5 kg block, it's going to be F net is equal to mass times acceleration. To find the net force, so we're going to use this positive, negative. Okay, so using that there, that means our T2 is going to be positive, T1 and W are going to be negative. But anyway, it's going to be F net is going to be equal to T2 plus negative T1 plus negative W is equal to MA. Then if we substitute T2, you must take note T2 here is equal to 250. 250 plus negative T1 plus the weight. Remember, the weight is equal to mg, which is equal to 5 times 9.8. So it's going to be minus 5 times 9.8 is equal to 5 times A. If we simplify this, it will give us our equation 1. And then for the 20 kg block, T1 plus negative W is equal to MA, and then T1 plus negative 20 times 9.8 is equal to 20A. Okay, so if we solve for the 5 kg log, we are going to see that we are going to get 201 minus T1 is equal to 5A is our equation 1, and we solve for the second one. For the 20 kg block, it's going to be T1 minus 196, which is equal to 20A. And we solve these two simultaneously. And if we solve these two simultaneously by adding them, it's going to be 201 minus T1 plus T1 minus 196 is equal to 5A plus 20A. This will give us 5 is equal to 25A, implying that divide by 25 divide by 25, it implies that our A is going to be equal to 5 over 25 meters per second, which is 0.2. So after that, we can choose any of those two equations. Remember, this is equation 1 and equation 2. So if I choose equation 2, it's going to be T1 minus 196 is equal to 20A. To get T1, it's going to be T1 minus 196 is equal to 20. A is 0.2 or 5 over 25. And then I solve for T1. T1 is going to be equal to 200 newtons, and of course it's downward. That will be our final answer there. And then the last question, they say when a 250 Newton force is replaced by a sharp pull on the string, one of the two strings break. Which one of the two strings, P or Q, will break? Okay, so if you're going to quickly pull this, or if you're going to exert a sharp pull here, what's going to happen is the force, remember we said the force here 250 is the same as the tension there. So if you're going to apply a very sharp force, that is going to be exerted exactly on T2. So obviously it's going to break on Q rather than on P. Thank you guys. Hope you find this helpful. And if you find it helpful, please like and subscribe. Thank you.